Hey everyone, Mr. Voikin here, and we're on Unit 5, Lesson 6. So basically we are taking everything that we've learned in this unit and we're sort of putting it together. These would definitely be like our level 7 type questions. So if we look at what they're asking us to do, they want us to solve the area of this figure. And you can see it's a complex shape, so it's made up of 2 or 3 different geometric shapes right now. So the 2 shapes that are going to be easiest to break this into are going to be a trapezoid and a rectangle. So rectangle is quite easy to recognize. It's going to be this one down, over, back up, and to that point right there. So that becomes our rectangle, and the trapezoid is sort of going to be right here like that. Okay, so that's going to be our trapezoid. The one that's in green and the one that's in pink is going to be our rectangle. Now to figure out the area of a rectangle, that's quite easy. It's length times width. So we could just basically say that that one is our length and that one is our width. For a trapezoid, it's going to be A plus B times H and divided by 2. Okay, so essentially what we want to do is go like that. So it's going to be A plus B multiplied by H and divided by 2. And we can basically do any one of these 3 once I have them in what order I want. So I can multiply, but definitely, what I have to do first is solve A plus B. Once I have that, I can divide it by 2, or I can multiply it by H, or I could multiply by H and then divide by 2. So it doesn't really matter the order you have, except for that needs to be done first, whatever's in brackets. Okay, so let's take a look at this shape we're calling a trapezoid. And what is the A, what is the B, and what is the H? Well, this is going to be the A up here, the length of that. This one down here will be B, and the H is going to be the height right there. Now, commonly you'll see a trapezoid looking like, sort of like that, where both the sides are flaring out like that, but in this case the height is where it is there because it's forming a 90-degree corner and it's not flaring out right there. On this trapezoid that I just drew down below, the height would actually be sort of that little spot that's right there, that little line going from B up perpendicular from B up to A. Okay, so it's important that you understand how to figure out the area of these 2 shapes right here. Now, how are we going to solve for each one of these? Well, you can see that these 2 lines that are right here, that line, and we have these 2 lines. What those are indicating is that length right here that I've got those 2 pink little hash marks, because there's 2 of them, it's the exact same length as that. So that means B right there is going to be equal to x plus 4. Okay, now what is A going to be equal to? Well, you can see that, just one second, get a different color. All the way from sort of like here down to that point right there is the 4x plus 9, and this part right here at the bottom, that's the 2x plus 3. So if I want to sort of get that length right there, it's going to be sort of that 4x plus 9 minus the 2x plus 3. Okay, so that's the first thing that we're going to solve right now. So let's solve for A. And I'll just change the thickness of that line. A is going to equal the 4x plus 9, and we're going to subtract from that the 2x plus 3. Okay, and remember, those need to be put into brackets because I'm subtracting that first polynomial and the second polynomial. Okay, now recognize we have that minus sign in the middle, so I'm going to have to change the sign of everything in the second polynomial and then just add them together. So this is going to be 4x plus 9 minus 2x, because it is inside the bracket, it is a positive 2x. So now it's going to be minus 2x, and it was a positive 3, so it's going to be minus 3. Combine like terms, 4x and negative 2x is going to give us a 2x. And I have a positive 9 and a negative 3, which is going to give us a positive 6. Okay, so that side A is going to equal 2x, is going to equal 2x plus 6. Okay, and we already know that B is equal to the x plus 4. Now, what about the height? So I need to calculate that height as well. So the height, let's take a look at this and see if we can figure it out, is going to be this side right here, which is 3x plus 6, and we're going to subtract from that this one right here, which is the x plus 4. Okay, so we know that to figure out the h, it's going to be 3x plus 6. Again, put that in brackets. We're going to subtract from that the x plus 4. Okay, now I'm going to do the same thing again, just rewrite it, but change the sign of everything in the second polynomial because we're subtracting. So minus x minus 4. And what we end up with is a 2x plus 2. Okay, so we have a 2x plus 2, and that will be the length of h. Okay, so now what we can start to do is figure out the actual area of some of these shapes now that we have all of our lengths that we need. So let's start off with the easy one, which is the rectangle, which is going to be, the rectangle is going to be the length, which is 2x plus 3 times the 3x plus 6. Okay, and now I'm just going to use FOIL to expand that out. So first of all, we have 2x times 3x, which is going to give us 6x squared. I'm going to do the outside, which is going to be 2x times 6, which is going to give us a positive 12x. I'm going to do the inside ones, 3 times 3x, which is going to give us a positive 9x. And finally, I'm going to do the last ones, which is 6 times 3, which is going to give us a positive 18. Okay, at this point, I need to gather all my like terms and put it in descending order. So I have 6x squareds, those are gone. You can see right here I've got a positive 12x and a positive 9x, giving us a total of positive 21x, and those are gone. And finally, I've got a positive 18, and done. So this one right here is the area of the rectangle. So area. Okay, so we've already had to solve sort of 3 different things. I've got the area of this rectangle right there, and now I need to solve the area of this trapezoid. So for the trapezoid, you can see that it's a plus b divided by 2 and times the h. Okay, so what do we have for a? Well, I solved that right here. And what do I have for b? I've got it right there. And what do I have for h? I've got it right there. Okay, so I need to grab those 3 numbers and just sort of substitute them into the right spots. So I've got a bracket and an a. So I've got 2 oops, that's definitely not a 2. A is going to be 2x plus 6. And I'm going to add to that b, which is x plus 4. Okay, and that's going to be in brackets. Now, I know I got to divide by 2 and multiply by h, but I'm going to work this one first. So I got 2x plus x is going to give me 3x. And I've got a 6 plus 4, which is going to give me a positive 10. Okay, and that can stay inside the brackets right there. And I'm going to have to divide by 2 and multiply by h, which is 2x plus 2. Okay, now remember, I can do this in any order that I want, but I'm sort of recognizing right here that 2 does not divide into 3 evenly, but it does divide into 10. So this is going to leave me with a fraction to work with. So I'm going to try multiplying it together first. So I'm just going to have to, again, use FOIL. So first time is the first, 3x times 2x is going to give us 6x squared. Then I'm going to move to the outside ones. 3x times 2 is going to give me a positive 6x. And then I have 10 times 2x, which is going to give me a positive 20x. And finally, I have 10 times 2, which is going to give me a positive 20. And just like we did over here, the next thing I need to do is gather like terms and put them in descending order. So I get 6x squared, that's gone. What do I have here? I've got a positive 6x and a positive 20x, giving me a total of positive 26x, gone and gone, and finally a plus 20. And this here would be the area of our trapezoid. So this is the area of the trapezoid right here, and this is the area of the rectangle. Now, to figure out the total area of this shape, I just obviously have to add those together. So I've got this one right here. I'm just going to add to it the 6x squared plus 21x. Just wait. Slow down, Mr. Boykin. Almost forgot. Be careful, be careful. Almost forgot that I need to divide by 2 right there. So I need to take this value right here and I need to now divide it by 2. Now essentially it's like doing the multiplication, the FOIL thing sort of, or feeding the chickens in reverse, right? So I can't just divide it into 1. This has to be able to divide into each one of those. Okay, so I end up with 6 divided by 2, which is 3x squared. 26 divided by 2 is 13x, and 20 divided by 2 is 10. Now I can bring over the 6x squared plus 21x plus 18, and I can add those two together. So what I'm going to get here is 9x squareds. I'm going to get 34 x's, and I'm going to get 28 as our value of the constant. Okay, now that would be the total area of that shape. Now let's go back and make sure we understand what they're asking us to do. So it says it's going to be in the form of a trinomial, ax squared plus bx plus c, and we are in that form right there. So we're 9x squared plus 34x plus 28. So you can see they're going oops, I'm going to switch over to my other pen here. This is going to be an ax squared plus bx plus c. So basically that 9 is my a. So a is equal to 9. B is equal to the 34, and it's a positive 34 as indicated by the positive sign in front. And the c is 28. Go back to the question. Determine the values of a, b, and c. And that is done. Sometimes they're going to ask you to, take those A, B, and C and go like A plus B divided by C, or add them all together or multiply them together. But in this case, they're just saying determine the values, and those are the values right there. So that is my final answer for that question. That's a big one. All right, let's take a look at class example number 2. And what does it say? We got a rectangular garden, so that's noteworthy right there. It's got a length that is 8 minus 3a, and the m at the end there are the units, so it's meters, and a width of a plus 8 meters, and inside there are 3 square flower beds, each with a side length of 2a plus 5 meters. And where it says the word square, that's going to be important, meaning that all 4 sides are the same. The rest is grass. It says draw a diagram to illustrate this. Okay, so that's, first of all, we're going to start off with the rectangular garden. Done. And then it says a length. So we'll call this the length down here, and this one can be the width. The length is a minus 3a, and those are going to be in meters. And the width is a plus 8. And again, that's going to be in meters. And the area is obviously length times width. Okay, and there are 3 square flower beds inside there. So 1 and 2 and 3. It doesn't really matter where they are in there as long as they're in there. And it says they have a side length. Now remember, all of these sides are the same right here. So I can put a single little slash. This side over here would be the same as that side, and this side right here would be the same as that side. And each one of these sides on the little flower bed is 2a plus 5, and again the units are going to be meters. Okay, so that would be the drawing done. The units are important, and laying it all out is important so that it can be easily read and understood. Okay, now it says write and simplify an expression for the area of the grass. Well, it's going to be the big rectangle minus those 3 little garden beds. So we'll do that, and then it says right here to determine the area of the grass if a was to equal negative 1.5. Okay, so it's going to be the area of the big rectangle, and that is going to be length times width, which is 8 minus 3a times a plus 8. So that's the big rectangle, and that's going to be minus 3 of the gardens, the area of those little flower pots or whatever they are, which is 2a plus 5 times 2a plus 5. So sort of like that. We're going to subtract those two. So the first thing I'm going to want to do is expand the left side here, and then deal with that part, and then multiply that by 3, and then subtract one from the other. So let's start on the left side. We'll just use basic FOIL. 8 times a is 8a. Outside would be 8 times 8, which is positive 64. Inside, negative 3 times a is negative 3a, and our last one is going to be negative 24a. That needs to be contained in the brackets. We're going to subtract from that. I'll deal with the 2 right here first. Okay, so we're going to get 2a times 2a, which is it's going to be 4a squared. I'm feeling like there should be a squared on this first one here somewhere. Negative 3 times a is negative 3a squared. Good. So 4a squared. Outside is 2a times 5, which is plus 10a. And inside plus 10a. And last is plus 25. So now I can take this 3 right here and multiply it by everything that's inside here right now. So what do we get? We get 3 times 4, which is 12a squared plus, 30a plus 30a plus 75. So that's all done now. That's going to be contained in brackets. I'm going to subtract from it this guy right here. So I can rewrite that by taking this. I'm just going to go copy that. Paste it right there. And paste another one. We'll put it back to where it should have been. And I really don't need this bracket anymore, but I do need to realize that if I'm going to subtract, I need to sort of change that to an addition, then change the sign of everything else that's inside here. So that is going to be minus 12a squared minus 30a minus 30a minus 75. Now I could have combined those first. Probably would make more sense doing that, but it still works. Okay, so let's look at putting this in descending order. So we'll go with our a squareds. I got a negative 3a squared and a negative 12a squared, which is going to be negative 15a squareds, and those are done. Let's move on to our a's. I got negative 30a. I got another negative 30a, I got another negative 24a, and I got a positive 8a. So that is going to be a total of, let's see, 30 and 30 is negative 60, negative 84. I just need to punch this on the calculator here really quickly. Okay, that's going to be a negative 76a. And finally, we're left with our constants. I got a positive 64, a negative 75 for a difference of 11 there. And that's sort of what we have worked out to that point. Now, if we look at the other part of the question right here, it states that determine the area of grass if A equals negative 1.5. Okay, and I also want to make note here that it's area, which tells me it's going to be units, and they need to be squared because that's what area is. So basically what I'm going to do is substitute each one of these a's with negative 1.5. So this is negative 15 times negative 1.5 squared minus 76 times negative 1.5 and then minus 11. And that literally just becomes a calculator exercise. We're going to jam everything into the calculator and then hit equals, and when you do that you should get no, not negative, sorry, 69 equals 69.25 meters squared. The units are meters, so the answer would be the grass area is 69.25 meters squared. I also want to go check and see if they've stated that I need to round it anywhere, and they haven't, so that looks good. Final answer, we are done. Beauty. Let's look at the final class example, number 3. So it says the hypotenuse of a right triangle. So we're going to make a right triangle, and we're going to say the hypotenuse has a length of 5x plus 5. Okay, and it actually gives us some units here as well, so make sure that you're making note of that. So this is in centimeters. And it says the other two sides, which really doesn't matter which one you choose, but just remember this is going to be C. We'll call this one A down here and this one B over here. We'll assign this one a 4x plus 8. And again, that's going to be with the centimeters. And this one down here, we'll give a 3x minus 5. And again, in centimeters. So those are the three lengths on a right triangle. And what does it say? Determine an equation and solve it to determine the length of all three sides. Okay, so basically I'm dealing with this right angle triangle, and I know the sort of ratio of the sides ends up being the c squared equals a squared plus b squared. So I can just go c squared, which is 5x plus 5 squared, equals the a squared, which is going to be 3x minus 5 squared, and I'm going to add to that the 4x plus 8, and that's going to be squared. Okay, so I'm going to have some numbers and some values that are going to have or a polynomial that's going to have an x, a degree of 1, and another polynomial that's going to have an x with a degree of 2, and somehow we need to solve for x and figure out what does the value of x equal. Then I will substitute whatever that value is into these x's that are right here, and that will allow me to solve for the actual numerical length of that side. So let's take a look at the c squared right here, which is going to be 5x plus 5 squared. And just remember, there's that rule that allows us to, because it's being squared, I can just basically go 25x squared and multiply the last two together, which is going to be plus 25. And then the middle one is going to be 5 times 5 times 2, okay, which is basically 50x. That's going to equal, well, let's do the same process on the other one. 3 times 3, which is 9x squared. Negative 5 times negative 5 is positive 25. And I get 3 times negative 5, which is negative 15, times 2 is going to be a negative 30x. Okay, and the last one, I'm going to add to that. 4 times 4 is 16x squared. 8 times 8 is 64. 4 times 8 is 32. Times 2 is going to be plus 64x. Plus 64. So now I've got this long string of polynomials. I've got degree 2, degree 1, and degree 0 polynomials. And I just need to gather the like terms and get the x's on the left and the numbers on the right, which is basic algebra solution to this problem. Okay, so let's start off with the x squareds. Well, what do I have here? I've got 9x squared on this side. So to move it to the left, if I want to take this 9x and move it over here, the 9x squared, what am I going to do? I'm going to subtract 9x squareds, which means I need to minus 9x squared from this side. Over here, I've got a positive 16x squared, so I'm going to minus 16x squared, and I'm going to minus 16x squared right here. So that's going to kill those ones. And now if you look at on this side, 25 minus 9 minus 16 is basically 0. So that gets eliminated as well. I've got no x squareds. So I can keep working within that long string right there, or I could simplify things and write it out for myself again. Equals negative 30x plus 25 plus 64x plus 64. Now remember what I said, we want anything that has an x with it on the left anything without an x on the right, and then I'll just solve for the x. So let's take, what do I have? I got negative 30x, so I'm going to add 30x right here, and I'm going to subtract 64x, and that will kill both of those. And if I add 30x to this side and subtract 64x right there, I'm going to end up with, let's see, 80 minus 64 is going to leave me with 16 x's. So I got 16 x's right there. Now on this side, what I'm going to do is I'm going to minus the 25 right there, which is going to kill that. Because this says equals, I got to do the same thing to the other side. So I'll minus 25. That's going to kill those 25s and leave me with this 64 right there. Now I need to solve for x by dividing both sides by 16, which cancels that. And I have x equals 4. Okay, now that I know the value of x, all I need to do is substitute those into the sides. So for side A, you can see that we had 3x minus 5, which is basically, for side A equals 3 times x, which is 4, minus 5, which equals 12 minus 5, which equals 7. For side B, it's going to be 4 times x, which was 4, plus 8. 4 times 4 is 16, plus 8 is 24. And for side C, we've got 5 times x, which is 4, plus 5. And that's going to be 20 plus 5, that's going to equal 25. And those are the final dimensions. And don't forget to put your units, otherwise you're going to lose marks on your presentation. And that is our final answer.